last class, we have already done with the introduction and some of the general characteristics of the solid state. Okay, now it's time to understand how the solids are classified, that is classification of solids. Okay, solids can be classified as crystalline or amorphous on the basis of a nature of a order present in the arrangement of their constituent particles. Based on the nature of order of present in the arrangement of their constituent particles, the solids can be classified into two types. They are crystalline and amorphous solids. Okay, they can be of two types, crystalline solids and amorphous solids. First we will learn in detail about the crystalline solids. Some of the important characteristics of the crystalline solids. There is an orderly arrangement of particles in a three-dimensional space. Okay, now the first property is all about shape, how the crystalline solids look. Have you seen sugar particles? Sugar have a perfect structure. They have a three-dimensional structure. They have a perfect geometrical shape. They have a definite characteristic geometrical shape. This point explains. There is an orderly arrangement of particles in three-dimensional space. They have definite and regular geometry throughout and thus have a long range order. They are very definite and have a perfect regular geometry. Sugar is a perfect, have a regular geometry. They have a good geometrical shapes, whereas compared to the amorphous solids, you can take example as a powder do not have any shape, that is they are very irregular in shape, but the crystalline solids are of three-dimensional space and have a perfect geometrical shape. They have a long range order. They have very long range order. Solids have long range order. They have sharp melting point. How they melt? They melt at a sharp and a characteristic temperature. They melt at a sharp and a characteristic temperature. They melt over a range of they do not melt over a range of a temperature, but they melt over a sharp melting point. They are anisotropic in nature. What is anisotropic and isotropic? What is anisotropic? Anisotropic, it shows the different value. It shows the different value when measured along the different directions in the same crystals. Consider the sugar crystals. When you observe it from different angles, it will be showing some different value along the different directions. But when you take about the powder particles, that is about amorphous, when you find it from the different direction, it will give you a same value. That is isotropic. Anisotropic is this, that will show different value when we observe from the different direction, but isotropic it will do not show different value when measured along the different directions. They are anisotropic in nature. Some physical properties like electrical resistance or refractive index will show different value when measured along the different directions in the same crystal. Okay. NaCl, diamond, CaCl, KCl, quartz, etc. are some of the examples of the crystalline solids. Okay. Another property of crystalline solids is cleavage property. They have a cleavage property. When you cut with a sharp edge tool, when you cut a solid particle with a sharp edged tool or knife, they split into two pieces. Obviously, they will split into two small pieces. They will split into two pieces, and the newly generated surface will be very plain and smooth. You can take example for any ball. If you cut it, it will be divided into two parts. The formed two particles are very soft and they are very plain. They have a definite heat of fusion. Okay, they have definite heat of fusion. These crystalline solids are called as true solids. They are called as true solids. They are called as true solids. Okay, crystalline solids are called as true solids. This is the two-dimensional structure of a crystalline solids. Anisotropy in a crystal. What is anisotropy? It gives different value when observed from the different directions. Anisotropy in crystals is due to different arrangement of particles along the different directions. Quartz, etc. Amorphous solid, that is a second part on the basis of a order of nature present. They consist of particles of a irregular shape. They do not have shape at all. For example, powder does not have any shape. They have an irregular shape. The arrangement of constituent particles has only short range order. They have only the short range order. They do not have long range order. They are very short in the order. They are said to be isotropic, whereas crystalline solids are said to be anisotropic because they can be found in the different directions. They are different in all the direction, whereas isotropic are same in all the directions, like electrical resistance or refractive index. Certain amorphous solids are called as supercooled liquids, whereas crystalline solids are called as true solids. Amorphous solids are called as supercooled liquids because they possess a characteristic similar to liquids. They have a characteristic similar to the liquids. Amorphous solids have the characteristic similar to liquids. This is supported by the fact that the glass of the window of some very old houses are found to be thicker at the bottom than at the top, showing fluidity possessed by the glass. These are called as pseudo solids. Okay, this is supported by the fact the glass of the window, which is very old, are found to be thicker at the bottom due to the flow of the liquids, showing the fluidity possessed by the glass. These are called as pseudo solids. For example, glass, rubber, plastic, polymers, etc. Here are some of the differences between the crystalline and amorphous solids. This is important for 2 marks. Okay, here are some of the important properties, that is shape, melting point, cleavage property, heat of fusion, anisotropic nature, order of arrangement of the constituent particles. Crystalline solids have a definite characteristic geometrical shape. They have a definite geometrical shape, whereas amorphous solids, they are irregular in shape. Melting point, they are melt at a sharp and characteristic temperature. Crystalline solids have a sharp melting point, whereas amorphous solids melt over a range of a temperature. Okay, their cleavage property, when cut with a sharp edge tool, they split into 2 pieces and newly generated surface are plain and smooth. When you cut a sugar, you find into 2 pieces, and the formed 2 pieces are very generated surfaces are very soft and very plain. Okay, but when in amorphous solids, when you cut with a sharp edge tool, that is a knife, etc., they cut into 2 pieces with the irregular surfaces. When you cut a powder pieces, you find the different irregular surfaces. Heat of fusion, that is solid to liquid. They have definite and characteristic of heat of fusion. They have definite heat of fusion, whereas amorphous solid do not have a definite heat of fusion. Anisotropic in nature. Crystalline solids are anisotropic in nature, that is they show different value when measured from different directions. When you measure a solid from different directions, you find the different values, whereas isotropic in nature, they get the same value when you measure it from the different direction, that is amorphous solid. They are called as true solids. Crystalline solids are known as true solids, whereas amorphous solids are called as pseudo solids or supercooled solids. They are called as pseudo solids because they possess the characteristics similar to the liquids. This is supported by the fact that glass of the window of some very old houses are found to be thicker at the bottom than at the top, showing some fluidity possessed by the glass. For example, you can take a glass. Order of arrangement, they have long range order, okay, whereas the amorphous solids have only the short range order.